Yeah, sure. Okay. So beginning again, my name is Thomas. I have got this small company called Android Devices. Here we basically design and develop embedded systems. So these are basically products which use microcontrollers to do stuff like that. So, uh, so this is literally the first product which I had developed. This was sometime in 2006. Okay, so this was before IoT was actually a word in the horizon. So what this was doing is, this was a check drop box. So in those times, you never used to have online payments. So this is like when the dinosaurs were roaming around, that kind of a situation. So in those times, what people used to do is, they used to come and drop a check in a box. Okay, and in the evening, somebody used to come and collect those checks, write it all by hand, and then send the checks to the bank. So we had kind of automated that entire system. So what here happens is, you come and put your check inside, it scans the check and reads the micro reader on the check, okay, and then you input your mobile number, etc., and it will store everything and send an SMS to the Hutch server. Hutch was a company back then.
Yes.
So then they used to kind of update their systems real time and send you an SMS back saying that we have received your payment. Okay, so this was literally one of the first products we had made. So initially this was the first product which I did some hacking or whatever you want to call it. So that's a Nokia phone you see up there. Okay, so we had actually read the protocol of that Nokia phone, and then we used to send SMSs via that Nokia phone by sending data from the microcontroller. Then we found that Nokia keeps updating their models, and then we used to have to keep changing. So then we went for a GSM modem. So this entire thing was done back then. And this is another similar product which we had made for Tata Indicom. This is a footfall tracker. They used to mount this on all their gallery kiosks and everything, and it used to count the number of people coming in and out. And then it used to send an SMS to the server saying that in this kiosk so many people have come in and out. So basically this was meant for, tracking if they make an ad, what is the effect of the ad, whether the number of footfalls have increased and stuff like that. So this was used for that. So feel free to stop me and ask me questions, otherwise I'll just keep rambling on. This is one of my bread and butter products which everybody keeps talking about. That's an elevator. That's a card which is used in an elevator. So when you push a button and all that, so the inputs come to this card, and then this card will actually decode what is the floor it is supposed to stop at. So when you have in some lifts you'll see there are 2 buttons, some lifts you'll see there are 1 button. So there's a lot of different things like down collective, up collective and all that stuff. So when you press a button for going up, and if the lift is going up, then only it will stop at that floor. Whereas if it was going down, it will not stop at that floor. So all that logic is built into these things. So if you see that biggest black color chip over there, that's basically what's called a microcontroller. So you would write code on your PC and then load it into that, and that does the thing.
So which MCU you were using?
Sorry?
Which MCU are you using?
Oh, it changes. It depends on the product wise. So this MCU, what had happened was, somebody somewhere, I got access to an auto rickshaw meter. Okay. so I opened that auto rickshaw meter, and then I saw what chip they were using inside. So the idea was that if it's used in an auto rickshaw, it will be a very robust chip. And since it's being used in such huge quantities, its rate will be cheap. So then I used that one for the lift. Okay.
So is it from ST or
Pardon me?
Is it from ST microcontroller?
No. This is from a company called Nuvoton. That's a Taiwanese semiconductor company. So STM, microchip, they are more expensive things. So this is meant for Janta industry. Okay. So this is what is like now. So this is what a lift panel looks like. So if you go to any lift room, which is right at the top, you'll see a panel like this. So that's the board which I am talking about, which is made by us. So those would get all the inputs and all coming from these wires and all that. Okay. and then it will decode it and send commands to this big box here. That's a drive. Okay, so that actually controls the motor which rotates the thing and takes the thing up and down. So that's what you heard. That was a contactor coming on. So you would have a huge motor and stuff like this, which will actually rotate it and bring it to your particular flow.
It's actually that guy is rotating, right?
Sorry?
Huh? That guy is in the picture, me rotate karta hu.
अच्छा उसका चेहरा है क्या? So yeah, so this is one of the products.
So do you sell these chips to like Otis and Kone?
No. So this is a separate bracket. What happens is Otis, Schindler, Kone, over a period of time when they sell it to all these societies, the people find it unaffordable to maintain that because they charge a bomb for doing that. So then what happens is our people go there and say, "Bhai, wo nikal do aur hamara dal do, ye bhi chalega." So then they put this and then take it. And of course, there are a lot of first installations and all that stuff. So we have provided almost something like 10,000 units of this running all over India. Okay, so this is another product of mine. So it's actually for fire detection. Okay, so if you see, there's a lot of fire detection things here also.
Yeah.
So those are those smoke detectors. So here, what happens is, now the smoke detector, what happens is you wait for the fire to have actually caught on and the smoke to have started generating, then you trigger the alarm. So these are mounted in bank vaults and stuff like that, okay, where they store things like currency notes and all that. So you don't want the fire to, like, you know, catch on in the thing and then detect it. So what this does is actually it detects the ultraviolet emitted by a fire. So it can detect a candle flame from something like this much distance. So it can detect both ultraviolet from a fire as well as from electric sparks. So this tube which you see there, that's actually manufactured by very few companies. So it's manufactured by a company called Hamamatsu in Japan. So the cost of the tube is something like 2,500, whereas a smoke detector is 700 rupees. Okay, so yeah, so what was nice about this was that tube actually requires 300 volts for excitation. Okay, so we are powering it with a 9-volt battery. So there is that little transformer there which actually generates that. So then, since it's powered by a battery, you want a long life and you want a long voltage. So then you write the code to kind of balance both. In the sense you send pulses, then go to sleep where the power consumption is low, then wake up again and that kind of a thing. So okay, there should be some voice here. So that's kind of the distance. So it can detect a candle flame, or actually we were using a lighter.
It needs line of sight.
A cone of, yeah, like a cone, divergent cone. So you would put multiple of these units. And the funny thing about this is, if this triggers, it will trigger the other one also. So if there are 2-3 of these units, if one triggers, it gets triggered by the other. So you have to mount them in such a way that they both don't see each other. And at the same time, that helps also because the area of coverage gets increased.
Does it sound like if one function is triggered, then other should be like?
So there's a whole bunch of products like this. So this is actually a servo stabilizer. These are used with CNC machines and all that. So wherever there are huge drives and all that, what happens in places like which are on the outskirts of Mumbai, the power is not so good, and most of the industrial units are generally centered there. So what happens in the evening or in the night, when a lot of the units shut down, the voltages go high. So if you are running a machine at that time, it's not bad. It's not good for that. So this would be basically monitoring the voltage and correcting it. So here you actually have to do a bit of engineering in the sense that you have to understand what is RMS voltage. Then you have to actually measure the sine wave bit by bit, do the computation, carry out that thing, and then do the correction. So these are kind of motors here, which you can see. So those motors actually rotate on that drum. That's a variac. Okay, so that's actually a transformer whose voltage can be varied. So that will rotate that and then maintain the voltage.
Can you not use electronics for this?
Yes, you can. But then what happens is, actually it will be much more faster than this.
And cheaper also.
No, it will be exorbitantly high. Okay, because these we are talking about like 100 kVA kind of loads. Okay, so if the load is less than say 5 kVA and stuff like that, then it might be somewhat on par. But when the loads become very high, then these kind of rule the roost. And the other thing about this is the equipment which this is actually servicing. It does not require fast correction. Okay, it basically requires that the voltage should be maintained in that range. So if you take the SMPS, which is for your laptop,
that's what I was coming to.
Yeah, so if you take the SMPS voltage of a laptop,
a consumer
exactly. So they say it will work from something like 90 volts to 280 volts.
Yeah.
Yes.
But if you actually operate it at 280 volts, its life will come down drastically. Okay, whereas it can take that 280 volt ka spike ya jo bhi hai. But if you operate it continuously at 280 volts, its life will deteriorate. So that's where these products come in. So they will centralize the voltage over a period of time so that, fine?
But basically the main thing is that the load is very
Correct,
high.
exactly. So you want to bring it to a safe operating range. Even though they have specified a high voltage, you don't want to operate it continuously at that voltage. So just to keep up with the flavor of the session, IoT or whatever you want to call it. So, so this was a mock-up I had made for somebody who wanted to actually see like what happened. So what I have done is I have my board there, which is the stabilizer board. Okay, and I have connected on that top. There's something called an ESP32. Okay, so through that ESP32, so any product can be made into an IoT product. It's just that you have to add a Wi-Fi module or something like that. Okay, so that is there. And then this is a free offering from Arduino called Arduino IoT Cloud. Okay, so to develop that product took me about 3 to 4 months. To get this working, it took me about 3 to 4 hours. Okay, basically because all the libraries and everything are all available. It's a matter of just understanding the thing and plugging it in. So it's kind of like a dashboard. Whatever is the voltage there will be,
ESPs work on the DC supply.
Yeah. Everything works on
the camera and catch up the questions.
Everything works on DC supply.
So how come you are able to get the 3-phase voltage?
Okay, great. So this that board, the main stabilizer board, that does all the calculations and everything. Okay, and then it connects to the ESP32 via UART. Okay, so whatever is the readings which are captured by that, only the readings are sent to that ESP32. So the ESP32 is not doing any processing whatsoever. It's only taking the data from here. So it's like connecting something to your laptop via the USB. So you just send all the data to that, and then that connects with all the Wi-Fi and does all the remaining part of the processing. So all the calculations of RMS and whatever, it's done by this board.
The black board.
Yeah, no, the one with that big display. And then that sends the data to that ESP32. And then, so the one more advantage of that is in case your ESP32 conks out, your product will still be working. So it's kind of distributed. So that is typically the route I would follow for any of my IoT products if I were to make something. I would have one to do actually all the heavy lifting and then probably use the ESP32 just for the connectivity. Of course, you can use ESP32 for doing all the calculations here also. But then, yeah, it's like what you wish to do. Yeah.
If you can throw light on the industry standards for these products.
Industry standards are, for example, for the stabilizer, okay, or the elevator, you have BIS standards. That is Indian ka standard hai. So you can download that standard which is pertinent to your product and see what kind of things. Like for example, if you take a stabilizer, they say that you should control the output voltage within plus or minus 2%. So that's what they give. They don't say that you have to use this code or you have to use these components, or they don't say that. They only say that what is the expected output from the product. So like for example, in the case of an elevator, they will specify that if there is a fire, so there is an input coming from a fire sensor to your card, then in that case, what should the lift do? As in, it should come to a particular floor for clearing out the people, or it should come down to the ground floor and not operate at all. So all those things are specified by the standard. But the standard never says that you have to use this microcontroller or you have to use these components or what like that.
So all voltage stabilizers will have UART or SPI or
No. See, this product is designed by me from scratch.
Okay, that's why it is.
Okay, so since there were some spare pins which I could route as a UART, just to give a demo, I had hooked up that and done it. So it depends on the microcontroller you use. If you use a very small, cheap microcontroller, it might not have enough pins to do that.
And you're using like a current transformer to...
Yeah, so there would be a CT, that's a current transformer, to measure the current.
Right.
Okay, and then for the voltage, that is 230 volts, I would use a resistive divider.
Okay.
So that would bring down the 230 volts to something which is like a 5 volt, which the microcontroller ADC can accept directly.
And your controller had an inbuilt ADC or?
Yes, this controller had 9 inbuilt ADC. So, it's for 3 phase. So 3 input voltages, 3 output voltages and 3 currents. So it got like used to the fullest.
Right.
Yeah.
Very satisfying when you use it.
Sorry?
It's very satisfying when you use all the peripherals.
Yeah, that is true. You get maximum money for your, maximum, in case it's a very high unit, to keep the transformer and everything inside, Google and stuff like that. Okay, so there's a whole bunch of products, so I don't know how much to actually go through. So I'll give this one. So this is something they call a holiday detector. Okay, basically it's a trade name kind of a thing. So you have all these huge pipes which go under the ground, which are used to convey like oil and whatnot. So all these pipes, they have a coating to inhibit corrosion, right? So if there is a pinhole or some porosity in that thing, what will happen is it will start corroding from that point. So what this equipment does is it basically detects any porosities in that coating. So this one is actually generating something like 8 to 30 kilovolts, okay, from a 12 volt battery. Okay, so when you pull this along, so one end of the pipe will be grounded, and the other one, that band which you are seeing, that would be carrying 8 to 30 kilovolts. So depending on the thickness of the coating, ASTM specifies that this much voltage has to be applied. So then you will be pulling it along, and if there is any porosity, it will pierce through that and give you a alarm. So then you can cut out that area and resurface it. So this is called a holiday detector. So like none of my products have any relation with each other. So anybody comes to me with their requirement, then I make things for them from scratch. This is the last product I'll talk about. So you have these huge pillars of concrete. So do you know how they crack from inside? So what happens is all these concrete pillars, they have an iron rod going through that, which is a rebar. So then the chlorine from the atmosphere, which is basically salt, NaCl, that will permeate through this concrete and start corroding that rebar inside. So when that rebar starts corroding, it will expand and that will crack the concrete. So again, there are standards which say that this is the amount of chlorine which can be allowed to pass through that thing. So this equipment basically checks that. So you take a concrete ka sample and you apply that voltage and see how much is the current passing through that. Monitor over a period of time, and then you know that it's a good quality concrete or not. So this is called RCP. So basically in all this, I am not inventing anything. There are standards which are specified. Like in this case, there are ASTM standards. So then you read those standards and see what is the voltage to be applied and what is to be measured, and then you automate the entire process. So this is what the test jig looks like. So these are like the 4 concrete samples. This equipment can measure 4 samples at one time. And then we gave a front end so that you can connect the thing via the USB, and it will log the entire thing. Because basically this test will be running for 30 days. So then you see all the trend of how much that the thing is going through, how much is the heating happening. You have to compensate for that. So stuff like that. So I'll now go through the methodologies for developing these products. So here, when the customer comes, first thing we ask is like, what are the design specifications? 99 out of 100 don't have a clue as to what they want. So then first thing we ask them is, do you have an existing product which you want to be made or something like that? Or whether there is any standard applying to that, then you read the standard and do that. Then you make a proof of concept using a breadboard or whatever and do the prototyping. Then you do field trials and debugging and all that. Then finally you go for the PCB assembly and testing. That's like the volume part of it. And what are the kind of skills which are used to develop products like this? It's basically you need to know coding in C, because most of the microcontrollers today, if not all, are coded in C, not C or C++, not C++, basically. And now, so I started all this stuff about 15 years back. That time it was more hostile territory. Now it's much more simpler, because a lot of these microcontroller manufacturers, they give a lot of software tools which are free, and like, you know, you can use it. And then you can use Arduino. That's a great platform to get started off if you're in the embedded space. And Arduino, the advantage is you can do a rapid test of your concept. If it works fine, you're a very lucky person. You can start like using that itself for that. But if it does not, then you can get more help and stuff like that. And then, yeah, so then there are other professional tools like Kyle, IAR, Rowdy. So the difference between those and open source tools is the code size of this will be very small. So in all this microcontrollers, the main thing is the code size. A microcontroller, which like the one which I use for the lift, it has got a ROM space of something like 64 KB and a RAM of something like 1 KB. So the entire logic has to run in that memory area. So then if the tool is good, it gives you a good concise hex file which can run on that thing. And now there's a hell of a lot of Chinese microcontrollers. Okay, they are damn good and they are damn cheap. So if you are really interested in beginning, the cost outlay which you have to do is minimal today. So, and there are a lot of evaluation boards. So you can just procure an evaluation board, write code on it, blink a LED and stuff like that, and do that. But fundamentally at the end of it, if you're developing a product professionally and you have experience with a particular product before, use that microcontroller until it is absolutely impossible to use that. Yeah, and tear down. So if you see a product, if you're genuinely interested in hardware, tear it down, see what's inside. So that's why I had opened that auto rickshaw meter and seen the IC and then used it somewhere else. And again, now for PCB design, you have a lot of open source stuff. Like, yeah.
So these Chinese components, now that AliExpress is banned in India now. No, this is a very genuine thing.
Yeah, go ahead.
How do I as an amateur enthusiast,
yeah,
I have to order like 2 or 3 just for a side project or
correct,
like for my satisfaction.
Correct.
How do I order it?
Yeah, so if it's...
Is he off the recording?
It's legit. So there are a lot of people in India like companies like Sunrom and Evelta and Electronics Comp. Okay, so whatever is the running products, so they import it and give it to you. So
Yeah,
you
but
can.
it's usually about like a niche product or like something like that.
Yeah, see again, like I said, no. So it always makes sense if you are making a product of yours.
No, it's just for me, like for an amateur or like for a
Correct.
side project.
So in that case, it makes sense to go with something like an Arduino, for example. It's not. It's only when it comes to volumes, that's when that cost advantage kicks in.
Yeah, but I'm not talking about controllers in specific. I'm talking about sensors and actuators and
All
stuff.
of that is available on a lot of websites. Like there's
Yeah,
Robo,
but there's like 10 times the markup.
Yeah, that's. See,
If something
AliExpress.
is available for 500 on say AliExpress.
There's this Pune-based company called Robo.in.
Yeah.
They
Yeah.
do a reasonable job. They are not.
They also have like the very common ones. They don't have something like.
They have a reasonably good range.
Or if you're so distant, you can take a loan and EMI working. No, I'm just kidding. But really, I'll tell you, I mean, compared to what was 15 years back, no? Today the scenario is totally different. Like he said, Robu and all, you would get most of the stuff from there. Okay, so and if you watch YouTube, so there is a lot of people who actually tear down stuff and all that. So I watch those YouTube videos, and then the first thing I do is I check whether those ICs are available locally. If they are available locally, great. Okay, if they are not available, then like, okay.
Try and error.
Yeah. So like now you have all these ARM Cortex and all that.
Yeah.
Now there is another architecture which is coming, thing called RISC-V. Okay, so that's competing with Cortex and all that, and that's an open source architecture. It's been developed by some US university, and like anybody can develop a chip with that framework. So now Chinese are making a lot of RISC-V products.
Actually, my question was actually more for like the sensors and the actuators and.
Correct. Yeah. I am a huge fan of AliExpress. So, like 2 years back, I used to get up in the morning wondering what is going to come from AliExpress today, because literally almost in a week I used to order.
Sad, I know it's going into a
But now you can
political
try
domain.
Banggood.
Yeah.
Okay, but Banggood doesn't give ICs and stuff. It only gives like products, multimeters and oscilloscopes and all those things at a very low rate. So that's still available.
Yeah, like because when you come to the IoT part, so like a 5G modem, right? If you want to buy a 5G modem like a head or something like that, in India, if you're going to buy it, it's like 25,000 rupees, like with all the bands, which is like more expensive than a phone. And like if you can get it from like AliExpress for 5,000-6,000, so like that kind of.
I really have not gone into that part of the space.
Yeah.
Okay, as in I've not got into the routers and those areas.
You are more like into the electronics. Right?
Exactly.
I'm talking a bit more towards the.
Exactly.
Yeah.
So even there is some open WRT and stuff like that, like where you can actually use existing modems.
But that's
and
for Wi-Fi. That's not for your 5Gs.
Okay, fine. So I mean, I'm sure the pain you face is faced by many. So there might be some workarounds if you actually.
But then for that we might have to close the recording.
I think everybody knows everything what's happening. Okay, fine. Okay, so then at the end of it, you have to actually make the PCB. So that's where you use tools like Eagle and KiCad. So now KiCad is very good, and it's a very robust, and it's a free open source software. So today, if somebody were to start designing PCBs, I would recommend KiCad. But before, Eagle was a very good offering. Now it's been taken over by AutoCAD, Autodesk, and all that stuff. Then there's something called LT Spice, which we will come to, and VCAD. So this is what LT Spice does for you. So before you make a product and actually put it on a PCB or a breadboard, you can actually simulate it. So this is like something like an optocoupler. Okay, so actually I can give the pulses and see what's the kind of pulses which are coming at the other end. So I can do all these simulations on the PC itself before actually doing that. And if you can simulate all these components pretty well, if you can model these components pretty well, it gives pretty good results. So this is a tool which I use extensively for analog design and all that kind of things. And this is a free. It's a remarkable tool, and they have given it for free. Okay, and this is another tool which I use all the time. It's called VCAD. Okay, so this is basically a PCB which has got just lines running across it. You can put your component, everything, and do. So you don't have to manufacture a PCB. You can use a general purpose PCB and do all your tests. And this is what it would look like after doing all that thing. And that's a breadboard. So you do all the testing with the breadboard, and then finally it comes down to a PCB like this. And like you can etch your own boards if you are so happy with it. Then there are a lot of tested it at 10 megahertz. They claim it can go up to 30 megahertz, but I have tested. But if you really pay the big bucks, you can go into the gigahertz, and that's where you will really have to take a loan and so that's like in like 25, 30 lakhs, companies like Tektronix and all those people. Yeah. So yeah, that's it. I mean, nothing more to say. So
I have one last question.
sure.
So writing the elevator logic is actually very complex.
Yeah. Okay.
I mean, I remember there was a
even
game.
blinking an LED is very complex for me. Okay.
Yeah, there was a game in software engineering. I don't know if some of you might have tried it, where you actually like write the logic and you write test cases for it, and then at each like stage the logic gets complicated, and like you have to write it in your own programming languages.
That's
like
true. What happens in my case is.
So do you automate those tests? Do you
No.
On the field?
Yes. No, not on the field. On the bench first.
Okay.
So instead of having that button in the car, you can actually put a button outside and give it directly to the PCB.
But you don't write automated test
No.
cases like we do.
I'm not intelligent enough to do that. So I actually write the code, and then so the idiom is that if you want to eat an elephant, you cut it into small pieces. So you cut the code into small segments. If it's an LED which is supposed to blink for this, then you write that part. Then if there's a switch and the LED is supposed to do that, you write that. Then compact the code together, test it extensively here, then go to the site and do that. And all products, no matter what kind of a genius you are,
That's it.
yeah. So they say that the best way to debug a product is to show it to an investor. So when you show it to that guy, automatically all kinds of bugs start surfacing which you have never seen before.
Yes, absolutely.
So yeah, so no matter how much good code you write or how much good hardware you write, there will be always somebody to help you out.
So when you do field testing, what all things do you test? And especially post prototyping, like once.
Correct. So I don't test anything. I do all my tests inside the office and on the bench. Then I give it to these guys who actually are going to use it and put it in the panel, and they do the testing. So when they do the testing, there's a whole bunch of other things which come. And also there's a lot of software problems which are solved by tightening screws. So when there is a problem, they say it's a software problem, actually it's a loose screw. So like I said, the outside environment finally has to be verified.
But like that cement testing box
Correct.
and stuff that you made, right? So you just did the PCB part or also the housing and everything associated with it?
No, I do mostly the PCB part and all that. Then, so I develop the electronics. The other fabrication part is generally done by my customer. They also do the marketing and the servicing. So I am kind of like, I get into the picture only when their people can't solve a problem. So my phone never rings. So if it rings, it's a problem. So it never rings. So that's good because it helps you to focus on development.
About tightening the screw, as a software guy, I just want to say that I always blame the hardware and things like that.
Absolutely. And here that is the problem, because I design the hardware as well as the software. So I have to fight with myself. So there is that thing, there is no I in teamwork. Here there is no team, only I. So yeah, so that's it.
Alright, I have a question.
Yeah, sure.
That, you said earlier that in your elevators and all the hardware that you develop, there's a limited space that is in KBs.
Correct.
So if we want to automate that all, then how can we fit that large code in that small KBs?
You can't. That's what I'm saying. So you have to use compilers and tools which are of that particular thing, which will give you that kind of thing, or you write code in such a way that it generates. So if somebody writes code in C,
Yeah.
there are different functions. So like there's a function called printf. Okay, so printf will generate a lot of code because it is catering to a lot of things like floating points, integers, etc., etc. And then there's another function called putS. So putS caters only to strings. So if you are outputting a string, use putS. Don't use printf. So in that case, your code size becomes smaller. So that's how you do like stuff like that. Fine? Okay. I don't know who's next. So. Yeah, thanks. Thank you.